Normal random variable, chapter 6. Normal random variables are examples of continuous random variables that can take on any value, not just whole numbers. We've already seen one example of a continuous random variable. That was the uniform random variable. So there's many examples of continuous random variables, but the main one that we'll be working with is the normal random variable, which has a bell-shaped graph. Probabilities of normal random variables with mean mu and standard deviation sigma are equal to areas under the bell-shaped curve, and this is the formula for the bell-shaped curve. We're not going to be really working with this formula. It requires calculus, but more than that, it requires it's a lot of computation, so it really requires a computer. But we're not going to be working with that formula, but we're going to be using tables that are computed with this formula. This formula, you'll see the special number pi, that's approximately 3.14. Special number e, that's approximately 2.71. So this is 1 over sigma, that's the standard deviation, times the square root of 2 pi times e, and then the exponent is x minus mu, that's the mean x minus mu quantity squared over 2 sigma squared. So anyway, that's the formula. But again, these probabilities are hard to compute. So we're going to be using this table here that gives standard normal probabilities. Okay, so example 1, duration of human pregnancy is approximately normal, with mean mu equal to 266 days and standard deviation sigma 16 days. So in symbols, x is distributed n, parentheses 266 comma 16. It means normal with mean mu 266 and standard deviation 16. Part A, we'd like the proportion of pregnancies that last less than 292 days. So in symbols, we want the probability that x is less than 292. And in order to use this table, we need to compute that to a z-score, because this table is not just any normal random variable, but it's a normal random variable with mean 0 and standard deviation 1. So it's if the original random variable is normal, then when we compute the z-score will have what's we call standard normal, which means the mean is 0 and the standard deviation is 1. So we want to compute a z-score here. So this is a probability that z is less than 292 minus 266 divided by 16. So that's the probability of, probably do this without a calculator, but I'll be lazy today. 292 minus 266 equals, divided by 16 equals, and I'll round this up to 1.63. So the probability that z is less than 1.63. So now we can look this up in the table. I'm going to make a picture before we look it up. We're going to look in row 1.6 and column 3 of the z table. But let me first make a picture here. Here's our z-score of 0. The mean z-score is going to be 0. Half the z-scores are above the mean, half are below the mean. But now 1.63, let's say that's about right here. What our table gives, it depends on how the table is set up, but usually a one-page z table only gives the probabilities of z being between 0 and the number. So this is the table here. this is what's in our table at least. And in the table, if we go to row 1.6, column 3, 1.6, and not the third column, but the column is labeled column 3, we see 0.4484. So that's what's in the table. It's 0.4484. But we want not just a z-scores between 0 and 1.63, but we also want the z-scores that are less than 0. So the whole bottom half is 0.5. So we want to add 0.5 plus the table here. So the answer is going to be 0.5 plus 0.4484, which would be 0.9484. Well, it's about 95%, approximately 95% of pregnancies last less than 292 days. Okay, so if you understand the pictures can help. But generally, if we're using our table, again, it depends on how the table is set up. But if you're using our table, if you see x less than a positive number, or z less than a positive number, I should say, z less than a positive number, it'll be 0.5. The probability you want is 0.5 plus the table. Okay, proportion of pregnancies lasting more than 292 days. So now we want this part over here, and I'll redraw this picture here. I'll redo the computation. Probably x is greater than 292, and make it into a z-score. Probability z is greater than 292 minus 266 over 16. Probability of z is greater than 1.63. So again, we look in row 1.6 in column 3. And here's our drawing. 0, let's say 1.63 here. And again, the table had 0.4484. But what we want is this piece here. And the whole upper half is 0.5. So the there's 0.5 here and there's 0.5 here. So anyway, to get this piece here, the probabilities correspond to the size of these shaded areas. To get this piece here, it's going to be 0.5 minus the table. So it's going to be 0.5 minus 0.4484. Be 0.0516. Okay. So there's about 5% chance that the pregnancies would last more than 292 days. So in general, if you see z greater than a positive number, you want to use 0.5 minus the table. But if you understand the pictures can help rather than try to memorize each situation. What proportion of pregnancies last about 292 days? Actually, we sort of for any continuous random variable. The probability x is exactly equal to a number is considered to be equal to 0. So again, the area, the probabilities correspond to the size of the shaded area under the curve. So if it's for x to be exactly equal to 1.63, there's no area there. There's just a single line. Otherwise, but anyway, anyway, if you want the proportion of pregnancies lasting about 292 days, rounded to the nearest whole number, then we can that will have a positive probability. That will have an area. So the probability of x is, say, approximately 292, and we're going to count everything as between 291.5 and 292.5. So add 0.5 and subtract 0.5, and then make each of these into z-scores by subtracting the mean dividing by the standard deviation. So 291.5 minus 266 over 16 less than z less than 292.5 minus 266 over 16. And so then we can put this in a calculator. 291.5 minus 266 equals, divided by 16 equals approximately 1.59. And then the other z-score, 292 minus 266 equals, divided by 16 equals approximately 1.66. Okay. So then we want to look at row 1.5, column 9, and 1.6 and column 6. Okay, so I'll make a picture here. I'm going to exaggerate this. This is not going to be to scale, but I'll just sort of exaggerate these intervals here. 1.59 and 1.66 are much closer together than what I'm going to draw them, but I think the graph is a little bit easier to see if I draw them like not completely right very close to each other. And okay, so let's. So if we look up 1.66, that corresponds to this, at least in our table here, that corresponds to this. Oops, this pen is no good. Okay, get rid of that pen. Get a different one. I'll try this one here. This one is better. Okay, so that so the way our table is set up, it has all the probabilities that are given are for the probabilities of z being between 0 and the given number. So if you look at 1.66, that's corresponds to the shaded area from 0 to 1.66, and then and that's actually more than what we want. We only want the part between 1.59 and 1.66. So what we want to do is subtract off the piece between 1.59 and 0, and that then what's going to be left is the piece between 1.59 and 1.66. So we want to look up both numbers and subtract the larger number minus the smaller number. So row 1.6, column 6, we have 4515. And then in row 1.5, column 9, 1.5, column 9, we have 4441. Okay, so then if we subtract, I'll get 4515 minus 0.4441, 0.0074. Okay, and again, the pictures can help. If you want to follow a rule, at least for our tables, the way our Z table is set up, for Z between two positive numbers, you want to look up both numbers and subtract. It's also true for Z between two negative numbers. If Z is between two numbers with the same sign, whether it's two positive or two negatives, you look up both numbers and subtract. Okay, so that's that answer there. If Z is between a positive and negative, then you would look up both numbers and add. So maybe I don't think I made a list of rules here. So let's for those of you that want a list of rules here, if you have, let's say Z is less than a positive, or Z is greater than a negative, use 0.5 plus the table. If you have Z is, let's say, greater than a positive, or Z less than a negative, you want to use 0.5 minus the table. If you have say Z between two positives, or Z between two negatives, is going to be a table minus table. If you have Z between a negative and a positive, you want to use table plus table. Okay, so that's if you want a list of rules to follow. And this works for our table. It's not going to work for any Z table, because not all Z tables are set up the same way. But the way our table is set up is a common way of doing it, but it's not the only way that it's done. Okay, so but if you understand the pictures can also help. That way you don't have to sort of memorize a set of rules here. I think the pictures kind of help your intuition also. The longest 3% of pregnancies last how long? So now we're instead of giving a value of X or a Z-score, we're giving a probability or percentage. So we want to use the Z table in reverse. So this one we're going to use Z table in reverse. So we want to look up Okay, well, that's okay. So the longest 3%. So that's so the longest 3% are going to be somewhere out here. So we're going to have some value z star, and with 3% or 0.03. And what's in the so this is what we want. And then what's going to be in the table is between 0 and z star. That's what's in the table. So it's going to be 0.5 minus 0.03, which is 0.47. 0.47. So this is what we want to look for in the table. And so we want to look for 0.4700 in the body of the z table. Okay. So let's go step 1. Call this step 1 here. Okay, so let's get the z table. And we're looking for 4700 in the body. And it's not there exactly. The closest numbers are 4699 and 4706. So if you look at, and they're both in row, I lost my place here, row 1.8. Row 1.8 and columns 8 and 9. Column 8 we have 0.4699, and column 9 we have 0.4706. So z star is going to be between is 1.88 and 1.89. It's closer to 1.88. If you look at the last digit, we're off by 1 here, and we're off by 6 there. So we could guesstimate maybe 1.881. So that's step 1. And then step 2, let me get another paper. Step 2, we want to solve x star minus the mean, which is 266, divided by the standard deviation, which is 16, equals to 1.881. So this is our z-score, and we want to find the x-score. So we want to multiply both sides by 16. And the 16s will cancel on the left side. These will cancel. And we'll have x star. Now we're doing intermediate algebra. X star minus 266 is equal to 1.881. 0.881 times 16. It's 30.096. And then we want to add 266 to both sides of the equal sign to get x star is equal to 296.096 days. So the longest 3% of pregnancies last over 296.096 days. So that's that one. The shortest 3% of pregnancies last how long? Okay, so let's make a picture here. Here's 0. Now we have the shortest 3% of pregnancies. So this is going to be 0.03. This is what we want. The table is actually on the positive side, so I'm going to put a minus z star here, but this is actually a positive side, but I put the minus sign to indicate it's the opposite of z star. So what's in the table is going to be 0.5 minus the 0.03. It's 47. So this is what's going to be in the table. But this side here is going to be the same as the table because the bell curve is symmetric. So we're still looking for 4,700 in the body of the z table. Again, the closest numbers are row 1.8, columns 8 and 9. So it's the same. We're going to have the same value as we had before, except it'll have the opposite sign. So it's 1.8, columns 8 and 9, 0.4699, and 0.4706. What's in the table is the opposite of z star. Opposite of z star is, let's say, approximately 1.881. It's between 1.88 and 1.89, but closer to 1.88. We guesstimate 1.881. But so that means that z star is going to be the opposite of that. Will be negative 1.881. So this is step 1. And step 2. Now we want to solve x star minus 266 over 16 is equal to a negative 1.881. So we can multiply both sides by 16. I won't show quite as much detail here because I'm running out of room on my page, but so multiply both sides by 16. The 16s cancel here, and we'll get the same number we had before, except with opposite sign. It'll be negative 30.096, and then add 266 to both sides, and we get x star is equal to 235.904 days. So the shortest 3% of pregnancies last less than 235.904 days. Okay, so another example here, part F. Find the 80th percentile for human pregnancy. In other words, the shortest 80% of pregnancies last how long? So generally the 80th percentile is more than 80% of the pregnancy. So that means that the shortest 80% pregnancies will correspond to the 80th percentile. So again, we can make a picture. Okay, so we want the lowest 80%. So so 50% of the z-scores are less than 0. So this is 0.5. But we need to go a little bit past that. So we want to go up to 30%, additional 30%, to get to 0.8. So so this whole, everything up to here is going to be 0.8 or 80%. Okay, so this is our z star is going to be right here. We want to look for 0.3000 in the body of the z table. Again, we're using the z table in reverse. Okay. So 3,000. It looks like its closest numbers are rows 0.8, columns 4 and 5. So it's 0.8. And in column 4 we have 2995. And in column 5 we have 3023. Okay, so our z-score is going to be, our z-star is between 0.84 and 0.85, but closer to 0.84. If you look at the last digit, we're off by 5 here and off by 23 there. So I would guesstimate z star is equal to 0.842. So this is step 1. Okay, and then step 2, we want to find the x score that goes with that, that z-score. So step 2, we want to solve x star minus 266 over 16 is equal to 0.842. Okay, so again we multiply both sides by 16. And on the left side, with the equal sign, the 16s will cancel. So we'll have x star minus 266 is equal to 0.842 times 16, 13.472. And then we want to add 266 to both sides to get x star is equal to 279.472 days. Okay. So the 80th percentile will be 79.472 days. Percentile is 279.472 days. So somebody having a pregnancy lasting that long would be more than 80% of the pregnancies. Okay, and that concludes this presentation.